This is Chapter 3. Chapter 3 deals a lot with graphing. We're going to be talking about equations that have both x and y most of the time. Okay, so this section is just kind of the basics, making sure we have the vocabulary and just a basic idea of how a graph works. Okay, so 3.1 is the rectangular coordinate system, which is something like this. We just have some sort of grid. I realize this is not beautiful, perfect, or anything like that, but we get the idea. Okay, this right here is the x-axis, and this is the y-axis. Okay, this point right here where they cross is called the origin. These are really two number lines that cross at 0. Okay, this is very naturally broken up into 4 pieces. Each of these pieces is called a quadrant. The prefix quad means 4. Now, I don't know why anybody decided to do this, but these quadrants are labeled in the following way. This is quadrant 1. They use Roman numerals. And then you go counterclockwise. This one is quadrant 2. This one's quadrant 3. And this one's quadrant 4. Okay? You're going to have some problems where they'll give you a point and ask which quadrant it's in. So if they gave you this, you would say it's in quadrant 1. If they gave you this, you'd say it's in quadrant 3. If they gave you this, you're also going to have the option of no quadrant. Basically, these problems, they'll be labeled A, B, C, D. You'll be asked, is it quadrant 1, 2, 3, 4, or no quadrant? You're going to say no quadrant whenever your point is on one of the axes lines. Okay? Now, these numbers go 1, 2, 3 this direction, 1, 2, 3 this direction, and then negatives down and negatives left. Just like on a number line. Number line on the x-axis, exactly the same way we've done it. And then this is logical. You want your positive numbers up, your negative numbers down. Okay, so how do we talk about points? Points are given as an ordered pair. And these are always your x-coordinate and then your y-coordinate. They go in alphabetical order. And yes, order does matter. Now, I know this looks a bit like interval notation. In fact, it looks a lot like interval notation. It's going to be context to the problem, whether or not you're talking about a point or if you're talking about a region. You'll be talking about a region when you have less thans or you have inequalities. But the problems we're going to be working in this section and most of this chapter, in fact, are going to have equal signs. And that's going to tell you it's an ordered pair. So what we would do is when we get asked to describe a point, so let's say I'll come back to this one. And I want to describe where it is. It's at 1, 2, 3, 4. That's where it lines up on the x-axis. So that would be 4. And then where does it line up on the y? 1, 2, 3, 4. It lines up with 4 on the y. So that's the point 4, 4. This point that I talked about here, where does it line up on the x-axis? It is at 1, 2, 3, 4, 5, 6, 7, 8, 9. That's negative 9. And that's where it lines up there. So your x value is negative 9. Then your y value, it lines up with negative 2. Now, you don't really want to draw these lines every time because, well, it's absolutely not necessary, and it's going to mess you up later if you continue to do that. But you can just make sure you're lining up, and you can use a ruler and see where they line up. It will help you if you're having trouble keeping things straight. Now, this point right here, where does it line up on the x-axis? It lines up at 0. And then this, where does it line up with on the y-axis? At 1, 2, 3. So that's the point 0, 3. Okay? So what we're going to be solving are linear equations in 2 variables, which is something that can generally be written in the form ax plus by is equal to c. Linear means that once we get these graphed, these are going to be straight lines. Also, when you see linear, you also know that your variables are not going to have an exponent on them. So no x squared, no x cubed, nothing like that. Most of the time, these are going to have two variables, x and y. There are some special cases where it's just one or the other. We will definitely be talking about those. This form is called standard form. Now, that is not so important in this section, but it will be important in later sections. We're going to be talking a lot more about standard form. Okay, so let's talk about these things. I want to complete these ordered pairs and then graph my answer. One thing I want to get through your heads is that a graph is solving the equation. We are finding the answers to the equation. This is not just a picture that your math teachers are mean about, making sure that you draw it perfectly. We're not just being picky, but we really are finding every single answer to these equations. Most of these have infinite solutions. Infinite, but not everything, okay? So let's just look at this. We have x minus y is equal to 5. This, basically, I have 4 little problems here. This one is telling me to plug in 0 for x and see what my y has to be. This one says plug in 0 for y and see what my x has to be. Remember, these are x and then y. So whichever coordinate you have, you're going to plug in and find the other one that goes with it. So starting here, if I let my x be 0, 0 minus y is equal to 5. Well, that's just negative y equal to 5. And if you have a negative variable instead of a positive variable, you just change the sign on both sides. So y equals negative 5. So the number that should go here is negative 5. Let's go ahead and plot this. Go to 0 on the x, which is here. Go to negative 5 on the y, which is right here at the bottom. Now, what that tells me is that this point is a solution to this equation. It's just one, though. There are infinite. Okay, so let's try this one. This time I'm going to plug in 0 for y. X minus 0 is equal to 5. So x is equal to 5. So a 5 would go right here. Let's go ahead and plot this point. I'm going to go to 5 on the x, 1, 2, 3, 4, 5, 0 on the y, which is right here. So that means this point is right here at the edge. Now, 2 points, that's enough to draw a line. But it's not enough to be sure that you have the correct line most of the time. Sometimes you're going to be really confident about your points. Sometimes you're not. This is probably my line. But I'm going to find these extra 2 points. And if these 2 do not line up, I've made a mistake somewhere. So you can think of these as insurance. Because if I graph this wrong, it could be any points. But once you have 3, if they all line up, you're pretty confident that you have it correct. So this one, it says to plug in 1 for x and see what we get. So 1 minus y is equal to 5. Let's subtract 1 from both sides to get negative y is equal to 4. So y must equal negative 4. So 1, negative 4. Let's plot that point. 1 on the x, negative 4 on the y. They line up right there. And it does fit my line. So I'm probably correct on all 3 of them. But we're asked to do the 4th one as well. And by the way, if you're asked to do all of these, you have to do all of these. Okay? 3 for x. 3 minus y is equal to 5. Let's subtract 3 from both sides. Negative y is equal to 2. Therefore, y equals negative 2. Negative 2 right here. 1, 2, 3 on the x. Negative 2 on the y is right there. So now use your line, your ruler, draw your straight line. Okay, so what we've done is we completed 4 ordered pairs, and we did this to get this graph. What we have now is a visual representation of every single solution to this equation. We have solved this equation by doing this graph. If I could read off the exact coordinates right there, some kind of fraction, some kind of decimal. But if I could read that off and plug it in here, it would work. If I knew this value, I could plug it in and work. If I extend this out 1,000,000 miles and pick a point, I could plug it in here and it would work. Okay?